This video demonstrates how to perform model evaluation using Python. Here we will use the scikit-learn library for performing the evaluation of model. Scikit-learn is one of the most popular Python libraries for machine learning. It provides models, datasets, and other useful functions. Model evaluation permits us to evaluate the performance of a model and compare different models to choose the best one to send into production. There are different techniques for model evaluation which depend upon the specific task which we want to solve. In this video, we will focus on two tasks, regression and classification. For each task, I will describe how to calculate the most popular metrics through a practical example. Let's begin. First, we will load our data sets. Here, I have used the wine quality dataset provided by UCI Machine Learning repo. Next, we will load the datasets as pandas data frame and then I will merge them. I have added a new column which contains the original dataset name, red or white. The dataset looks like the following table. It contains 6,497 rows and 13 columns. Now I will define a function which will encode all the categorical columns. I will also define another function which scales the numerical columns. Next, we will evaluate a regression model. The most popular matrices are absolute mean error, root mean squared error, R2 score. As a regression task, I want to predict the pH of each record given the other features. I define x and y variable as follows. X equal to df.drop pH, axis equals to 1 and y equals to df pH. Then I transform these categories into numbers as I scale those numbers. As a result, I will split the data sets into training set and test set. Next, I will define an auxiliary function that receives an input the model, then it trains the test. Next, I will build a linear regression model and then test its performance. As an output, the run experiment function returns results. I will also build another regression model based on stochastic gradient descent. Next, a comparison of two experiments shows that linear regressor has a lower RMSE, thus it outperforms the other model. Now we will perform classification. The most common evaluation metrics for classification are precision. Among all the positive prediction, count how many of them are really positive. And the second is recall. Among all the real positive cases, count how many of them are predicted positive. And the last one is accuracy. Among all cases, count how many of them have been predicted correctly. As a classification task, I consider the prediction of the target class red-white. Thus, I built the x and y variable as follows. X equals df.drop. The parameters are target and axis equals 1. And y equals df target. Now, I will transform the categorical columns into numerical columns. Then scale all the numerical columns. I also encode the target classes. Now I will split the data sets into training set and test set and define an auxiliary function that receives the model as an input. It trains and tests it by calculating the previously defined matrix. This is that code. Then I will build a random forest classifier which will calculate the performance. In terms of accuracy, the random forest classifier outperforms the decision tree classifier. This is how we have performed model evaluation for classification and regression in scikit-learn. The described techniques do not consider parameter optimization because the purpose of this video was to show the most common evaluation metrics.